So for our project, we're going to be doing a Khan Academy style explanation of L'Hopital's rule. So first off, when do we need to use L'Hopital's rule? Sometimes we're going to have limits of x approaching a of a rational function, so f of x over g of x, with an answer that's 0 over 0, infinity over infinity, or negative infinity over negative infinity. When we have those types of answers, we actually have an indeterminate form. So essentially, in these scenarios, we can use L'Hopital's rule. Now, this may seem slightly counterintuitive. Thus far in class, we've kind of gone over that when you see a limit like this one with a rational function, we use the quotient rule. Generally, we would see f of x over g of x and think to immediately apply this type of derivative. But the thing that L'Hopital's rule does is it kind of simplifies. If we are faced with one of these limits, and the answer is an indeterminate form, then we can solve by taking the derivative of the numerator and the denominator individually. So that's our rule. That's L'Hopital's rule written out. And now we're going to head into some examples. Okay, so for our first example, we're going to go over the limit of sine of 5x over 7x as x approaches 0. The first step is to check if you have an indeterminate form as the answer to your limit. So what you can do is substitute in 0 for x. You see that you get 0 over 0. That's an indeterminate form. Sometimes it also can be helpful to check back on what your indeterminate forms are, so feel free to do that. But after finishing the check, we know that we can use L'Hopital's rule. So to remind ourselves of what L'Hopital's rule is, we're just going to rewrite before we start taking derivatives. You may notice that we're taking the derivative of sine of 5x, which means that we're still going to have to use the chain rule. One thing to keep in mind is that when you're using L'Hopital's rule, you still have to use all of the other derivative rules. So we're going to go through the chain rule together. In order to not confuse the variables, we're using L and M. So first, we write out our terms, and then we're going to take the derivatives of the terms individually. After doing that, we're going to remind ourselves of the chain rule, and then we can apply everything together. So we know that, at least for the numerator, our answer will be 5 cosine of 5x. Now, after doing that, we have to fully take the derivative of both top and bottom. So essentially, we're going to put everything together. So the limit of x as sine of 5x over 7x approaches 0 is equivalent to the derivative of sine of 5x over the derivative of 7x. So we're going to use what we just found, 5 cosine of 5x, and then take the derivative of 7x to get 7. So we're almost at our final step. After finding the derivatives of the numerator and the denominator, we now can substitute in 0 for x. So now we have our final answer, and we're going to put a box over the entire thing. So the limit of sine of 5x over 7x as x approaches 0 is 5/7. Now we're going to head into our second example. So now we have the limit of 4 ln x over x as x approaches negative infinity. As you see, we're going to first do our check to make sure that our answer will be an indeterminate form. After doing this, we know that negative infinity over negative infinity is an indeterminate form. So, we're going to use L'Hopital's rule. Again, as a general rule, we're always going to write out the rule before we start the equation, just to make sure we do everything correctly. So after doing this, we're going to start by taking the derivatives of the numerator and the denominator separately. So we're writing out what we're about to do. After doing this, we're now going to input the derivatives that we found. And then in our final step, we're going to have to substitute in negative infinity in the x. A quick step to help us could be simplifying slightly so that we are left with 4 over x. After getting this answer, we have 4 over negative infinity. Because that's the denominator term is going to get infinitely bigger, we know that our answer will be 0. So now we're just going to write out our final value. For our third example of the limit of 3 of x over e to the x as x approaches infinity, we're going to go a little bit faster to mirror a test or a classwork assignment. So first we're doing our check. And we know immediately that this is going to be an indeterminate form because infinity is over infinity, and we know that we're going to use L'Hopital's rule. Within this example, we're going to still show all of our work. And with that, we're going to write out the rule. Then we're going to substitute in our terms. After doing that, we're going to take the derivative of the numerator and the denominator individually. With our final step, we have to substitute in infinity for x. Because the denominator is getting infinitely bigger, you know that the answer will be 0. And we write out our final answer and put a box. Okay, so some of our takeaways were you need to remember the indeterminate forms. And this is super important because it ensures that you can check to make sure that the rule is applicable. If it's not applicable, then you're going to have to use the quotient rule. Then finally, make sure to do all the other rules while you're applying L'Hopital's rule, like in our first example, how we use the chain rule.